Bismillahirrahmanirrahim. Today we will discuss about the symmetry and the symmetry operation. So let's start. So, as you can know, recently I will discuss about the inversion center and plane of axis already discussed in the previous lecture. And this is which symmetry operation in which there is a reflection through the center of symmetry, and if reflection of all the part of the molecule through the center of the molecule basically produces indistinguishable configuration, and the center is called as the center of symmetry, and it's called the center of inversion, and its designated by the symbol I. Each of the molecule, carbon dioxide, trans N2F4, SF6, and the benzene possesses center of symmetry. And each point moves to the center of the molecule to a possible opposite the original position, and as far from the center point as where it started. As you can see here, X, Y, Z, when they invert it, they are in the negative sign as they change the position. Similarly, there is a center of inversion when they invert. After inversion, they have different positions of the molecules attached with this center of symmetry. There is a different type of a molecule, ethane and the methane. As you can see, there is no center of inversion in methane, and in ethane there is a center of inversion. Through these, hydrogen attached are symbolized as 1 2 3 4 5 6, and after inverted molecule, as you can closely see that they are inverted the configuration as different molecules, right from left. And other symmetry operation is identity. Identity operation causes no change in molecule. No atom does actually change its position. It is included for the mathematical completion. And identity operation is characteristics of the center of the molecule. It has if there has no other symmetry possible in it. So another rotation is another symmetry operation is improper axis of rotation, which is characterized as SN rotation and the deflection axis of symmetry. This is basically is the symmetry operation rotation axis followed by the deflection through a plane of perpendicular to this axis. If rotation through the 360 divided by n about an axis followed by the reflection through a plane perpendicular to the that axis yields indistinguishable configuration, and the axis is basically n-fold rotation, and this reflection axis is called as an n-fold improper rotation axis. So tetrahedral species of the type X4, all Y groups must equivalent, possesses the S4 axis, three S4 axis, and operation of one S4 rotation and reflection in methane molecule. As you can see here is the molecule, which is axis bisect SCH bond angle rotate about the 90 degree. After this, it reflects through the plane that is perpendicular to its original axis, and basically this operation reflects the axis of improper axis of rotation. Improper rotation basically SN involves the rotation about the 360 divided by n followed by the deflection through the plane that is perpendicular to the rotation axis. Operation about one of the S4 axis in S4, and three S4 operations are possible for the methane molecule. Here are some angles, rotation angles and symmetry operations. If 90 degree, then symmetry operation is S4. If 180, C2 S4 square, 270 S4 cube, 360 it's S4 4. Here is the first S4 conversion, and below is a S4 second conversion, in which one is basically S4, then C4, and then Saturn correlation. Okay, you can see here the some examples, symmetry element shapes and some examples. E basically identity. This shape SIHC or B4F, it has no other symmetry operation rather than only E. So that's why it's symbolical element shapes an example elaborated that it has only one operation, which is called as a E. Another H2O2 in this, only E1 and C2 symmetry elements are present. In next E2 and plane of symmetry, then E1, C2, and mirror planes at the vertical center. Example are hydrogen peroxide, NHF2, sulfur dioxide, chlorine, and water. Similarly, in ammonia, PCl3 and POCl3, there is E1, 2, C3, and 3 sigma B symmetry elements. In N2O4B to 6, there are basically E1, 3, C2, I, and 3 sigma inverted centers. At the end, there is a SF in which identity, and similarly 8 CC3, 6 C4, 6 C, C2I, 6S4, and 8S6, 3 in mirror image, 6 D, sigma D. So these are basically all the examples and the glimpses of the today lecture, which we elaborated about the symmetry elements. Hope so that you will be much know about the symmetry and the symmetry elements. This is full lecture for all understanding of the figures and symmetry elements. Thank you so much.